So welcome everybody to another installment of Tech Field Day. My name is Chris Young, at NetmanChris on Twitter, and I work for HP Networking in the Global Business Unit as a technical marketing engineer. So I'm here to talk to you guys a little bit today about some of the stuff that we've been doing in honor of the event, SDN related, and basically that's me, and I hope it's a good conversation.
I'm Matt Oswald, network engineer.
Ethan Banks, network engineer.
Pete Welcher, network engineer with Chesapeake Net Craftsman, Cisco Gold Partner.
I'm Chris Margett. I'm a network engineer.
Ed Henry, network engineer.
Gideon Tam, network engineer.
Excellent. So, we had a chance and opportunity to talk a lot last night, and one of the things that we wanted to give you guys an opportunity to kind of bring you up to speed is really kind of what HP has been doing around SDN. So we're going to do a really quick recap in the last episode of, right? So if you go back in time a little bit around 2010, we actually did Packet Pushers podcast show 25. So if you're looking, I don't know what, you guys are at 130, something like that at this point in time?
Almost 190.
Yeah, 190. So yeah, there's quite a while ago. And one of our ATG, our Office of the CTO, actually introduced the concept kind of out of academia into the Packet Pushers audience at that point in time, right? So that was a while ago. And then we kind of went almost dead silent for about a year. Right, and that's really, if you think back, 2010, 2011, kind of, there was a lot of hype going on, and we often get asked, what were you guys doing during that time? So we were actually working, right? And that's at least the explanation I offer to you, and I hope you guys judge me on that later. And then we came out in 2013 again and started doing a few more SDN discussions, right? And these are, we'll get these all these links in the show links. So you guys can go back and do your research for anybody who's not familiar with anything we're doing, so I don't have to ad nauseum go over all this stuff, right? And then when we really started coming out again around TFD, Tech Field Day at Interop New York last year, right? So we started launching our VAN SDN controller, which is a full OpenFlow controller, which has been GA'd, totally available. As well, we started talking about an SDN ecosystem, right? And really talking about things like an app store and what we're doing from a partnering standpoint, and looking at some of the use cases and some of the things that are kind of unique around what we're doing is our SDN story is not all focused around OpenStack and the data center. Right, which is a little bit different than what some of the other vendors are doing right now, right? We actually view a lot of use cases in campus environments. So again, videos available, right? We also at I think TFT at this particular one, we introduced the IMC SDN management module. So we're still, to the best of my knowledge, one of the only vendors actually looking and talking about management and operations in an SDN world and what actually that means, right? So that's kind of a different slant that we're trying to look at this from the entire story, from infrastructure all the way up to the management layer, right? Which I think a lot of people still confuse what is management versus the controller. Some people consider the controller to be management, right? And then we came in and we talked about to you guys at ONUG last year, so that was November, right? And we talked about a couple of different applications, which were Sentinel, right? So that was the code name at that point in time. And we also talked about a UCNC link optimizer, right? And these are both campus-focused applications, which have since been actually GA'd, right? So you can actually buy, and we are selling these for real, like there's customers actually purchasing them. This isn't just, fluff that we're talking about now. You can buy these applications, right? So Network Protector is what was known as Sentinel, and Network Optimizer is the UCNC link application, right? And from a UCNC standpoint, this was really us. I know there's other vendors that have talked to and have released apps from Microsoft, but this was, I think we spent, Jacob, 2 years working with Microsoft on around the APIs and developing the API layer cake. This is the foundational stuff that everybody's kind of going, is any of this real? Well, it takes time to build that foundation, right? And we're starting to get to that point. And then, 2-3 weeks ago, something like that, Interop Las Vegas happened. And normally I'm trying to put product slides in here, but this is one of our greatest little products. So Sarwar Raza, who is part of our Office of the CTO, we'll sell him too if you want. And Sarwar is actually doing some really, really interesting work with the ONF as well around the Northbound Interface Committee, right? And really trying to talk to the industry and figure out from a common standpoint. HP really as a company is really this almost annoying commitment in some ways to open standards, right? We're trying to do everything we possibly can to make sure that the customer has as much wide open choice as possible, and that if you choose to be an HP customer, it's because you have a choice and you like us and you like what we're doing, not because we've locked you in some proprietary way. So this kind of the state, and this is what Sarwa was talking about of SDN at the moment, is there's, everybody's doing their own APIs. Every app has to write to a separate API, and we're starting to see fragmentation, which is normal where we are in the industry. But as an industry, for us to kind of move forward, we think that hopefully there's going to have to be some standardization around APIs, so you can have cross-platform applications and some really cool stuff there. So again, Sarwar is, you can check out those videos as well. Which brings us to today, right? So we've done a lot of talking. I've done a lot of talking on HP, right? We don't live in this industry by ourselves. We don't pretend that we're the only company that is out there, right? And although we do some great stuff, we also realize that kind of requires an ecosystem of partners, right? So this is where you're probably going to look at it and go, what is he doing? Yeah. So yes, I used a Gartner slide in a TFD presentation. I did it there, right? So little up, most top in the visionary quadrant was HP from the data center. So you guys, whatever your opinion is on Gartner, it is what it is. But what was really interesting here, one of the quotes from this was HP continues to lead the established networking vendors with respect to SDN, right? Which a lot of people, may or may not agree with that, but I would offer you, this is why. So to the best of my knowledge, HP is the only vendor in the entire industry still offering infrastructure layer products. So you can still get a 3500 YL that you bought 7 years ago and put OpenFlow 1.3 code on it, right? Pretty much everything that we have now will run OpenFlow 1.3. Not completely there, but mostly there, right? Our own controller, right? So we're actually offering an AV-G8, our own controller. We've also done some announcements, and we've done some interoperability testing with NEC, so that if you don't like our controller, at least our infrastructure products will work with somebody else's, right? So we recognize
With
that.
a programmable flow controller.
Yeah.
Yeah.
Yeah. We've also offering our own apps, right? So we've got our own apps that we're offering, so Network Protector, Network Optimizer, and of course there's, we do internal hackathons, and we're going to continue to see more stuff come out as far as the SDN App Store as well. So we're trying to provide a venue for people to actually monetize applications, right? It would be nice if people just did things out of the goodness of their heart, but
The SDN App Store is still an HP-focused store.
it is, there's a lot of similarities between the Apple Store, right?
Yeah.
So right now, yeah, obviously we need to build apps into it to get it to come, but what we're going to quickly get to here is our partners and our ecosystem that is coming to the play that are also offering apps into the App Store, right? So, and that's really what we want, is we want a place where anybody can write an app, and we will provide that background infrastructure to be able to help them monetize it, sell it, provide the support, checking, all that kind of stuff, right? And of course, as part of IMC, as part of our network management platform, really provide that management layer and that infrastructure management, controller management, and app management layer from an SDN standpoint. Because SDN starts to bring in a lot of real interesting problems as far as, we've got these protocols like OpenFlow, like OFconfig, all these different things out there. But what are we doing from a fault management standpoint? When a DPID has a power supply that goes dead or is in imminent failure, one of those, the wonderful traps, operating outside of normal operating procedures, phone TAC, phone HP, TS, whoever you need to phone for your vendor, get it replaced before an imminent failure happens. OF's got no knowledge of that, right? So we've done some interesting things as far as try to figure out, release management when you've got multiple controllers, right? The omniscient controller, singular controller isn't going to happen. So how do you take an application when Network Protector 1.3 comes out and goes to 1.4? How do you make sure that all your controllers, from a release management standpoint, are actually running the right version of code, right? So there's a lot of really interesting things that we've done with our controller specifically.
So you just said all your controllers. So do you have some sort of controller federation going on, or?
So we do have controller federation internally. So like you would never have a singular controller. You would have multiple controllers doing controller federation in a controller group, right? But you may also have multiple controller groups in multiple different sites dealing with different functions.
Yeah, what most vendors are still talking
Yeah.
about are not federated controllers. They're talking about a cluster of controllers that are redundant and back each other
Yeah.
up, but not multiple SDN domains that are federated together in some way.
So no, not in that sense yet. Although we're also working with VMware on the federation between NSX and the VAN SDN to take underlay and overlay and provide a signaling mechanism between the two of them to be able to do some interesting stuff when everything goes into a VXLAN. Right. So there's a ton of stuff that we did some blog posts, Jacob, on VMware's site as well. We did some joint posts, and we've been talking about that for a while. So that's Jacob Rapp, who's not on camera, so he's also here with us. But there's a ton of stuff going on that a lot of people, quite frankly, just are not aware of what we've been doing and how much we've actually been doing it, right? So, like I said, we can't do this alone, right? We just simply can't. So we have to kind of seed the market. We have to work with vendors to get APIs. We have to have our own controller and have a very consistent and try to have the most productive APIs available for them to be able to consume. We had to get the infrastructure layer in place and get the code and figure out the 1.3 and tables and all that stuff. And we're at the point now where we're actually starting to bring in a partner ecosystem so that it's not just us in the App Store. Right? We don't want to be the only player here. We want to be able to offer choice and be that infrastructure layer, hopefully be the controller layer, and eventually, you can buy a Riverbed app, or you could buy a Radware, or you could buy whoever you want to buy and still use it with our controller, right? So, which is kind of where we're at today. So at Interop, there was a lot of announcements that happened in Interop, right? And you guys may have seen this, may not have, but we actually came out and we talked about a bunch of partner apps, which we're going to introduce you to briefly to some of them today. And then we've actually got our partner in here, GuardiCore, as well, to talk to you about their specific app, which is from just a technical perspective. It's kind of cool what they're doing, right? It's a different application. So just some of the use cases, BlueCat. So BlueCat, IPAM, right? Some of you may know them. What they're basically doing, again, in a lot of cases, and on all the apps are kind of doing this policy out to the campus edge, where if you look at things, industry trends like BYOD, let me throw out the buzzwords, right? It creates some interesting issues around DNS. Malware, obviously, there's DNS issues with malware as well. So DNS is definitely an exploitable place in the network where you can still do some very nasty things. So their application actually goes in and programs the edge to take any DNS queries that come out and forward them to the corporate DNS server independent of where it thought it was supposed to go, and return it from the same, looking like it's coming from the same IP address. So whatever the corporate DNS policy is at that point, you can't access the servers that you shouldn't be able to from a DNS standpoint, right? And they can actually make sure that if there's any malware within the organization, it's really hardening the edge, right? So it's kind of interesting stuff.
It's an intercept and not a proxy?
It's an intercept and not a proxy.
Yeah, interesting.
Yeah. Absolutely. So, and really this, you guys will have the slides, and what we're going to do is actually get a Dropbox for you guys as well. So you'll have there's some videos of this stuff, but for time, I'm not going to go through them all, right? But yeah, in general, DNS query is intercepted, forwarded over to the BlueCat DNS to the IPAM servers, and whatever appropriate policy is applied at that point, right? So campus, not data center, right? Someone brings in their iPad, someone brings in their MacBook, their HP laptop, whatever it is. It doesn't matter what DNS they have on it. They can't circumvent your policy anymore. So your policy is now hardened at a network edge level, right? So really interesting stuff. Radware, they actually did a distributed denial of service, right? So again, they're turning the edge of the network into a sensor array, right? And at that point, when they start seeing this abnormal traffic, they can actually take that, intercept it, and redirect it to the Radware Defense Pro box, and be able to then scrub the traffic rather than having to, again, have these monolithic boxes. That's one of a lot of the use cases from a security standpoint from a SDN, from an OpenFlow specific, tend to be like this right now, where it's going to eventually lower your cost because you're not going to have these monolithic boxes necessarily in the middle of the network somewhere.
So you said this sits out at the edge of the network. So what are we talking about? Access layer switches running OpenFlow,
Yep.
And data being inspected by a Radware.
So you're going to have
process
OpenFlow
somewhere?
rules, right? And basically you're going to come in and it's going to look at, based on the OpenFlow rule set, and they're going to start to look at all the different applications, look at the session state, look at what sessions are happening, is there open TCP sessions, all that kind of stuff sitting there. And
it's the VAN controller that's sitting in the middle of all this, though.
It's the VAN controller that's doing all the orchestration, right? So the VAN controller is, it's just the control plane, right? So the actual application is telling it what program rules to what what program rules to the van controller. The van controller will push them to the infrastructure layer. The infrastructure layer will do what it does. It forwards traffic based on that rule set, right? Based on the fib, right? Again, really kind of interesting application that this stuff is not, it's not slideware. We're actually proof of concepting all of these applications today with customers, right? You know, this is, again, this is all kind of new stuff that's going on. So there's a lot of people that, you know, especially as we're hearing at this event, nobody is going to just blindly trust that this is all going to work the first time properly, right? But we as an industry right now, and I think 2014 is, we're starting to see people doing this a lot. You know, carving out architectural blocks of their network where they're going to put a little piece in. And from a campus standpoint, honestly, it's beautiful because who cares when 24 users go out, right? Your data center, people get a little more excited about that, right? Evolve, so from eCode. So this is, in a nutshell, this is an automation simulation tool from an OpenFlow standpoint. So it'll actually look at your network, figure out what the paths look like, allow you to create and orchestrate, and then push that policy back out, right? Hyperglance, hybrid cloud, and it will allow you to take your data models from different sources and then actually show you in a 3D modeling exactly what the relationship is and where things are, right? So there's some really, really cool stuff in here which we will be happy to get you all the videos on.
Yeah, the real status engine is pretty cool. Is this visualizing flows? Because I've only ever seen that engine used for like a 3D modeling of a physical infrastructure, not flows.
It's doing flows, and this is from a hybrid cloud, right? So it'll basically allow you to take from your multiple sources and then show you per individual flows, per workflow, per workload, and it's still, they're still continuing to evolve and make it better, right? So we're gonna see as things, you know, this is, I think the most interesting thing about this is, you know, and I used this analogy last night, in some senses we're actually just changing the laws of gravity. We're changing a fundamental law way down to the bottom. So we need to look at the implications of what that means and what do these new capabilities to be able to program the fib at that low level beyond all the normal network control stuff that we've had for years. What does that actually mean, right? And I think we're going to start seeing a lot of that stuff. We're going to stumble as an industry. There's going to be, you know, some catastrophic things that happen because someone's going to do something silly they shouldn't have. And we're going to keep moving on and learning, right? So this, for me, this is probably the year where the hype just will die down and the reality will start to become real, and you know, that all of us hopefully will start getting more operational experience and sharing that.
Well, I like that point because for me it comes down to use cases, and one of the challenges I've had around OpenFlow is real use cases other than, yeah, we can make your switches into a gigamon, for example. The other thing I am hearing here that I like is a focus on targeting flows or redirecting traffic, although I noticed your use cases were more edge than actually fabric. And to me, one of the challenges, and it may be my preconception, is I don't want to deal with all flows because there are way too many of them. And I think people want to deal with not just elephant flows, but key flows from a security perspective, perhaps. And so I'm kind of liking that aspect of what I hear here. What I'm worried about with this product is that it's reminding me of one of my pet phobias. I've dealt with some large VLAN layer 2 networks where you end up with the giant wall chart trying to show which VLANs extend where. And I'm sort of seeing this as an automated version of that, except maybe even more granular because it's dealing with flows rather than VLANs. And to me, that's kind of the whole problem with the VLAN-oriented design, is that I like it when they stop because then I can modularize my diagramming and my understanding of what's going on.
I think I said this last year, but I think if you really wanted to change the world with SDN, it would be sensibly designed networks, right? Not software designed. No application is ever going to replace good design, like plain and simple, right?
Well, one theme that I'm not hearing is, although I think it's lurking, for instance, behind what Glue Networks was saying, is that automation is going to force us to standardize design models. And so when I hear a vendor saying, we'll do an arbitrary topology, I cringe, because to me it's, no, you need to get to an automatable topology with a repeatable base unit.
I think that's a really interesting question, right? Because if you look at like basically the whole NSX, at least from me not being VMware and from an external perspective and not having any access to internal docs, what they're doing, so I'll take what I say with a grain of salt, please, but that's the entire point, is to have completely arbitrary topologies that are completely removed from what the physical reality of the network is. So I think it's this real interesting kind of, we as networking engineers, as the low level, the guys who actually deal with cables and hardware, are going to have to get a lot better at how we do things and share things with the younger generation, because there's people, they still don't understand Spanish.
I don't know about an arbitrary topology. I think it doesn't, NSX, if you want to talk about that, just doesn't care what the topology is. So, and I think there's a subtle difference there.
Okay.
It presumes delivery
Yeah.
to the endpoints that are talking to each other, and doesn't care what it is, which doesn't mean you can still build an arbitrary topology. It still should be something that's well designed. I'm picking at nits there, but
Yeah, I know, I see your point. I get concerned with some of the, non-networking people that.
So
Yes.
I'm reminded of what another vendor said. I won't name who the vendor was, but we supply the rope, and if you hang yourself, it's your own doggone fault. And so the power, with great power comes great responsibility, is the other quote that maybe applies.
Absolutely.
So Chris and I were talking this morning about a context where just with current networking tools, traffic ends up going through a device. I think you said 24 times or something ridiculous like that, as it snakes through between firewall layers and a switch.
Yeah.
And it's clear that you can do that in a virtual or an OpenFlow world, but it's also maybe not an optimal thing to do in terms of your hardware.
Yep. So, and with that, what I wanted to do is to allow GuardiCore, who's one of our partners, who's actually here at ONUG with us, to actually come up and talk to you guys specifically about what their app is doing, right?
So my name is Dror Sal'i. I come from Israel, from a company called GuardiCore. Our mission in life is to secure data centers. And our view of data centers is that you have pretty advanced security around them on the perimeter, but very basic stuff inside. And it's not coincidence. You have so much traffic, east-west traffic is so overwhelming that you can't do too much to inspect it. And we think that SDN enables you to change that paradigm and enables us to rethink about what security actually is all about. And this is one application. We are actually a stealthy mode company, so most of what we do we keep to ourselves, but there's one application, like an appetizer, showing what SDN can actually mean to security. And maybe we can move to, okay. So the idea here is to look at what happens when there is an attacker, an APT or some sort of malware, it could be an inside guy, doing something bad inside the network. And we analyze what's happening, and one of the first things that is happening is what we call active network mapping. So the guy did some sniffing, he knows something about the topology of the network, and then he's trying to propagate to other computers. However, he does not know the full topology, he does not know the security policy. And what you typically find inside data center is some sort of separation, VLAN separation, local firewalls, and by design, that phase of the attacker will generate failed connections. He will try to connect to a specific port on a specific machine and will be blocked, or that specific port is closed. Now, maybe we can move to the next slide. What you typically see when a connection is blocked is, best case, a log on a firewall. And if it is a VLAN separation, you just don't see anything. And the analogy is, consider a guy walking here in the offices, trying to open doors. If there's a good policy, they will, some of the first doors he's trying to open will be closed, locked. But nobody is asking him, why are you trying to open this door? What are you trying to do? Eventually, he will find an open door because the data center has to work, so there will be some connections available. Then he will exploit them and he will proceed. This is how things happen, and that's why typically when an attacker gets inside data center, this is a game over. And we are changing this equation. And this application, what it does, it's looking for failed connections in the network and identifies them through the networking elements, through the switches. And when this happens, it does not let the connection die. So let's say there's an RST packet coming in, and once it arrives, it will kill the connection. It drops that packet and instead redirects that connection to an investigation machine. So honeypots have been there. It's an old concept, but they were always waiting for the attacker to find them. This specific honeypot finds the attacker. The traffic is redirected to the honeypot. It opens the service that the failed connection was looking for, and then it is monitoring what's happening. In that phase, it's relatively easy to distinguish between benign misconfiguration, let's say a printer server looking for his drivers in the wrong place, or something malicious. If one virtual machine is executing shellcode on the other one, it doesn't look good. If it's downloading backdoor, we know something bad has happened. So what we here get is a very low false positive tool which detects an attack on a data center.
So for the successful connections, you don't look at it at all, right? You just let it pass through and don't do any inspection, right? Or you still inspection, but you tell the access layer, so to speak, right, to just let it go. Don't do anything.
We don't mess with a successful connection. Talk to us about a year from now. Maybe we'll tell you what we do with the successful connection.
Yeah, because right now they inside a data center moving to a higher bandwidth, 40 gig, 100 gig, right? So
right.
It's a high bandwidth traffic.
Yes.
If you don't look at all this successful traffic, then you will not slow down the high bandwidth infrastructure.
You got it. So our whole view about defending the east-west traffic is that you have no chance to inspect the full traffic, and the whole trick is to use the programmability of the switches, use the capabilities of the SDN in order not to look at all of the traffic, but to look only at a fraction of the traffic. In the same time, there are things that attackers do which can be exposed even by looking at a small fraction of the traffic. This is one example of this. So we look only at missed connections. Obviously, it's a very small fraction. By the way, there are quite a lot of those in a data center, but still, percentage-wise, it's a very small percentage of the traffic. So yes, and the whole game is to look at the fraction of the traffic, but find the unique attributes of an attack.
When you say missed connections, you had mentioned TCP reset. Oh, I see a TCP reset. I'm going to intercept that and redirect this traffic over to the honeypot.
So
What about just a SYN with no SYN-ACK?
Right. So do you want to give the mic?
Presumably you'd want a threshold too, in case somebody just
Yeah, that's
fingered a
right.
password.
So
And then what about non-TCP traffic as well?
So first of all, you're absolutely right. There are a few types of blocked connections. So we're talking about SYN and RST. We're talking about unanswered SYNs. Of course, we don't intervene after one unanswered SYN. We wait to see like 3 tries. And on the 3rd try, we say, okay, we gave the other computer a chance to answer. Now we redirect it to our own machine. And this is talking about existing computers. Now, if someone tries to access a non-existing computer, it won't be TCP, it will be an ARP request, right? It will be an ARP request with no reply. So we look at these as well. We look.
Not between segments, though.
It depends, right?
Yeah.
Within the same segment, but usually it tries first that an attacker will try to scan the same segment. So we catch these ARP requests and we just redirect it to our own computer. And regarding which services, it depends, because if it tries to access TCP port 22 for SSH, we want to answer with an SSH service which has some maybe vulnerabilities, maybe something which will lure him. So it's port specific, right? We're waiting for traffic which we can emulate in the service emulation machine. So it will be for specific services.
Is the trigger network packets, or is the trigger the firewall log that you mentioned earlier?
Network packets. We install OpenFlow rules.
Okay, so it's okay.
Which
You
catch
mentioned
these.
You see a log in the firewall earlier,
Right.
but
No,
it's
we
not a
mentioned
log.
That's in today's world. The network administrator or security guy will see a log, but we actually
OpenFlow rules?
right. So we install. We use the northbound API of the HP controller, and we install OpenFlow rules on Open vSwitch or any virtual switches which are in the hypervisors. We use Nicira extensions because we're actually doing TCP flag matching. We're doing advanced stuff in order to catch these. And then we
Okay, so
we
you're actually
redirect
doing
it.
a pretty stiff tuple match
Right,
in the
right.
OpenFlow switches.
It's not even it's not a 5-double. It's different. Like
Yeah.
TCP flags. It's
Yeah.
a bit different.
You must be collecting all the reset packets in order to stop them, because
Right.
it's too late otherwise, right?
Right.
Right. And so
But reset packets are the only one we need to actually collect, because SYN packets we just mirror we don't need to like
And ARP, you have time. You can answer later.
exactly.
So you're also doing some NAT on the destination and
Right. For the redirection, exactly.
Now, so this sounds like an argument I've heard from another vendor where part of this is the economic cost of attack and tying up your hacker with trying to fool the honeypot.
Now, the amazing thing about this is that in the end, the security administrator not only gets a line which says someone tried to access something, he actually gets a full forensic report. If the guy tried to download the tool, then the forensic report actually contains the attachment. This is the tool he tries to download, this is the URL he accessed. Yeah. Because this emulation machine is inspected from the outside, it's debugged, so we know every single stage, we can replay the attack, and we think it's really valuable.
So one of the ideas that I've heard in another context was to actually try to fingerprint the attacker on the honeypot and then feed that into a global information, and presumably you are aware of that, so preaching to the choir.
How well does this scale? Because there's a lot of east-west traffic in data centers.
Right, so for instance, let's take the ARP packet. So ARP packets today already go to the controller. We're not doing anything new regarding that, right? Because it already goes there. What we're doing with RST and SYNC packets is we're not doing all the processing in the controller, because that would be crazy. We're installing very small modules in hypervisors, which do, for instance, if you want to count the scenes, we want to only answer after 3 scenes. This is not necessarily something we can do with OpenFlow. So we install a local module on hypervisors.
Virtual machine.
Either a virtual machine or a process on the hypervisor itself, which counts the scenes. So the traffic it needs to handle is a very small amount, a small fraction of the traffic, because it's only for the VMs which are on that hypervisor, and that's how we separate.
So this, you really want this to be in a virtual switch? Are you really anticipating that the virtual switch is the edge, not necessarily a physical switch?
It has to be.
Has to be.
It has to be.
No, it can be also a physical switch, definitely. It's very easy for us to work with a virtual switch, because the virtual switch would be always the first place, the first one who sees a new packet coming from a virtual machine. But in some specific scenarios, we are also using physical switches.
Well, and not every data center is fully virtualized either, of course. So.
Right. Of course.
All right. Thank you.
Thank you.
Thanks.
That's awesome.
And with that, I hope this was informative for you guys. If you guys have any questions, we'll make sure there's links on the website in the show notes and all that kind of good stuff. hp.com/go/SDN, vanity URL, really easy to get there, where you can find more about, videos of all the apps that you've seen here, PDFs, download the Van SDN controller, all that kind of stuff. So, and if you guys got any questions, always @NetmanChris on Twitter. And thank you all for your time.